Hey everyone, my name is Steven. I work at Restero, and today I wanted to talk about ZK scaling between the layers. So first of all, an overview of kind of what scaling looks like today. We're kind of stuck, right? I think in the past decade, we've made a lot of progress. We've gone from Ethereum and EVM with smart contracts to Solana and SVM and more TPS. We've built out rollups like Optimism Arbitrum. And then in the past year and over the next year, we're seeing like this parallel VM sort of concept with Aptos, Monad, MegaETH, and all those teams. But for all practical purposes, the DevX here still kind of sucks. Developers need to build in EVM and SVM, which despite people's beliefs here, it kind of sucks compared to Python. They need to think about block times, finality, consensus, all these things that traditionally, if I'm a developer in Fang, I don't need to think about. And this kind of boils down to the simple fact that blockchains are limited in functionality and performance due to consensus. There's only so much data you can derive consensus around with a set of validators, and this is simply due to the limitations of networking and physics. And what this means is we actually have to do quite a lot of compromises with our blockchain design, and we're just trying to cram as much performance as possible into the limitations that basically we have with networking. So we actually think there's a possible way to close this gap, and really the main solution here might be using ZK. So the idea I kind of want to talk through today is this idea of a ZK coprocessor. I think we frequently hear the term thrown around, but like what exactly is a coprocessor? To figure that out, I went on Google and searched up what is a coprocessor. A coprocessor is a microprocessor designed to supplement the capabilities of a primary processor. That doesn't really tell us much, but we can make some assumptions here, right? The primary processor in this case might be Ethereum or any base layer or settlement layer. And then how have we been supplementing the capabilities of Ethereum? That has been with rollups, right? So using this definition, I think we can make a somewhat argument that rollups are coprocessors as they supplement the performance and functionality of Ethereum. So a new way I kind of want us to think about coprocessors is that they are a generalization of the larger scaling frameworks that we adopt. Now, this includes rollups, this includes plasmas and validiums, but all of these concepts are things that were developed before ZK was really like proliferated in protocol design. So what else have we not explored? I think the question I kind of wanted to ask is, can we build a coprocessor without a blockchain? Like, why are we trying to scale blockchains by building other blockchains on top of them? As they still have the limitations of consensus, right? So if we're able to build a coprocessor without a blockchain, it frees the developer from EVM, SVM, MoveVM, etc. It lets them develop without thinking about gas and finality and block times. And most importantly, it lets them build like normal. It lets them build programs like normal, which I think is always the end goal here. So one way we can think about building coprocessors without blockchains is to use ZK, right? ZK allows us to verify the validity of compute without any consensus. You don't need a bunch of validators to agree on the transaction's validity. All you need is a single proof of correctness. So in turn, you can basically use these verifiable off-chain ZK programs as coprocessors. And these programs are written in 100% native Rust. They have unlimited compute with an asterisk, of course, but at its core, it's just a program. It's just the same Rust program that you wrote in college. It doesn't have to deal with any of the complexities that come with on-chain development. So like, what does this mean in practice, right? Going back to the title of this talk, here are the layers, and here is how we've done development so far, right? You deploy Uniswap on Ethereum, and if you want to deploy it on another chain, you need to redeploy all the contracts. For all practical purposes, the Uniswap on Optimism and the Uniswap on Ethereum are separate siloed applications, right? There's really minimal interoperability, composability between them. It's just two applications deployed in two different areas. But what if we can put it between the chains, right? What if we move the applications off of the chains and stick them somewhere in between? The idea we're kind of thinking about now is, can we take the core compute that Uniswap, for example, uses, that is the swapping logic, the liquidity pool logic, put it in a zkVM guest program, so that's your ZK coprocessor, and then call it from any chain. So a user from Ethereum or Optimism can request a swap. They'll send these inputs to the coprocessor program, which will actually do the compute, and then the resulting response will be submitted on-chain, where the state balances will update. And this isn't just restricted to like Ethereum and Optimism, right? We can go for chains like Polygon and also go for things that aren't even EVM, like Solana. In all these cases, users can request compute, request the swap, and the ZK coprocessor will do the math and return it back on chain for the state change. What this might look like in more detail is like, take for example, you have account balances A equals 1 and B equals 1, and you're trying to do the math problem, A plus B equals C. Traditionally, you need to submit a transaction on Ethereum, which goes into the mempool, and the validators will agree on it, and then they'll give you a response. But that takes a lot of gas, and if this was a really complex math problem, it'd be really expensive. Instead, the user will submit all these account balances directly to the coprocessor, and this is fully off-chain, like via a REST API. The coprocessor does the math, and then the coprocessor will return the result of this math, as well as the proof attesting to the validity of this math, onto Ethereum. And then Ethereum can conduct the state change. And the real key here is Ethereum never had to do the math, right? It just proves, it just trusts the verified proof, trusts the ZK proof by verifying it, and never has to spend the gas to do the computation itself. So two real-world examples that we've been working with teams to build out. In the first case, we've been working with an order book that thought about building an app chain, right? But app chains kind of suck, and that might be a little controversial here, but they kind of do. They have low liquidity, they have poor interoperability. The UX is totally unintuitive because it requires bridging and like swapping networks. There's long latency because most app chains still have 1 to 2 second block times, which for the sake of an order book is basically not that useful. And they have a huge developer lift. There's multiple teams with millions of dollars of funding. They have to go into an app chain, modify the validator logic, modify the consensus to try to push the TPS as high as possible. And there's a lot of projects trying to do this. But what if we don't use an app chain? What if we don't use a blockchain to run the order book itself? What if we run the order book fully off-chain on a centralized server? The order book itself looks just like Binance and Coinbase, and it runs with sub-second latencies. So the users can send bids, send asks. They can interact with the order book in the same interface they would use to interact with Coinbase. But the real difference here and how it's connected back on-chain is all the bids and asks, as well as the order matching engine and the liquidation engine, are passed through the zkVM. Subsequently, you're able to basically generate a lagging validity proof of the validity of the order book's execution, and then you're able to post this proof on Ethereum, which lets you update the state balances and allows you to finally withdraw your assets. So at least for the user standpoint, as I mentioned before, the bids and asks are totally free. The latency is sub-second. So they're just trading on any other exchange. And the real difference here is with this proof, they're able to do this directly on-chain, directly via their MetaMask. And at least for this experience, you're able to tap into like Ethereum Layer 1 liquidity and deal with none of the issues that app chains normally have to deal with. And with this design, we've actually been working with Hashflow to build this out into a full product. Another problem that folks face is like rollups don't really scale, right? Like a Uniswap V2 swap costs about $1 on Ethereum, which I checked yesterday, so it does fluctuate, and it costs about 5 cents on Optimism and Arbitrum. These are good numbers, but they're not great, and with the performant applications people are trying to build, the gas fees are still kind of high. And then rollups aren't really fast. As I mentioned before, like soft finality can take more than a second, and hard finality, at least for optimistic rollups, takes about 7 days. So we've actually been working with Automata, which is building out like a TE-based coprocessor. And as part of that, they need to verify these SGX attestations on-chain. They implemented this verification logic in EVM, and it takes 8 million gas. And there's basically nothing on the market today where you can run an 8 million gas smart contract in a reasonable cost. No rollups can do that. Maybe something in the future, but they really want to keep the costs like sub-cents. So they came to the coprocessor, right? And instead of running all of this verification logic on-chain, they ran it in a ZK VM. And currently the cost to prove that is under 5 cents, and obviously we're working very hard to drop that number down. And then you take that proof and you can verify that on-chain, which costs only 20K gas with aggregation, or 250K gas, worst case scenario, without any sort of aggregation. So the really exciting thing about all of this is building coprocessors is actually quite easy. Just in the past year, I think ZK VMs have become really popular and really functional in performance. And most importantly, they let you build circuits without any cryptography, without any math skills, but in 100% native Rust. When you build a coprocessor, and at least with our Foundry template, you really need to just work with 3 components. You need to touch your existing smart contract, which sends the inputs and handles the callback. You need to work with a Rust-based ZKVM program, which is where you put the majority of your compute. And then there's a Rust-based serialization file, which basically translates the on-chain data structures to the Rust data structures. But we're actively looking to abstract away that part. But the key here is you don't need to build out all of the components that traditional rollups need, right? You can get really performant custom compute without needing to touch like validator logic, block building, building out a custom VM, RPC, modifying consensus. You don't need to touch any of that in order to scale your application. And we think that will really make this a lot more accessible for the average application developer. So when I thought about like the impact of this on Web3, we broke it down into like the 3 main areas that we feel like people are pushing on, right? That being scaling, interoperability, and accessibility. On the scaling side, ZK is getting really fast, right? The cost to prove an Ethereum transaction in the ZK VM is already sub-cent, and it was probably 10 cents just a year ago. And I think by the end of the year, we're going to get it below 0.1 of a cent. And at least across the standard cryptographic primitives that most developers would use, the RISC-0 ZKVM, and I mean, just generally the rest of the industry as a whole has really been pushing these costs, these proving times, all the way down. So more and more, as we look towards the future, you'll really be able to prove everything and anything. Also, the coprocessor basically allows you to build a single application as a Rust program, and you can call this from any chain, right? So instead of having to refactor or rebuild your program to be run on like Optimism and Solana, you can run it once and build it once in Rust, and users can then call your coprocessor from any chain, right? Whether it be Ethereum or Solana or Optimism, maybe Bitcoin in the future as they keep on pushing BitVM and things like that. All of these are seamlessly connected via ZK. You don't need to think about cross-chain message passing. You don't need to think about bridging or anything like that, because like for the order book, for example, the state, the count balances all live on the coprocessor itself. The state doesn't have to actually live on each individual chain. You don't have to sync all of that up. Everything lives on the coprocessor. And finally, with regards to accessibility, and this is personally what I'm most excited about, building a ZK coprocessor is really accessible from both the DevX side of things and the UX side of things. For the developer, you're just building in Rust. It's 100% native Rust. You have native Rust traits, and you can fork any sort of Rust repo. It doesn't have to be some Rust code that was optimized for Web3, just literally anything. And then for the user side of things, ZK allows us to connect the Web 2 interfaces with Web 3. Things like Google login, Apple login, even things like KYC. These will actually make it so that interfaces to interact with Web 3 applications can be trustlessly bridged with Web 2. And that is generally, I think, how we'll bring more developers and more users onto crypto. So I think in conclusion, innovations in the ZK space are enabling new architectures, solutions, and possibilities. I really challenge developers to think about the problems they're facing with their application development and maybe understand that not everything needs to be on-chain. Thanks to ZK and verifiability, we can do compute without the constraints of consensus and blockchains and networking. Kind of a funny way I thought about saying this is I want us to reject modernity, reject EVM, reject Solidity, and reject all that on-chain development, and embrace tradition, right? The tradition of Web 2 development, the tradition of development that led you to have all those apps on your phones with millions and millions of users. And thanks to ZK, we can basically bridge that gap, right? Bridge the gap between this traditional development and Web 3. Cool, thank you.